Is equal to Ii plus beta into I naught. I naught is Ai into Ii. In these two terms, you see Ii is common. So take Ii outside, 1 plus beta into Ai. So the input resistance formula is given by RIF is equal to VI by IS. And substitute the expression for IS. VI by 1 plus beta AI into II. VI by II, you know it is RI. So RIF equal to RI by 1 plus beta into AI. So RIF equal to RI by 1 plus beta into AI. Remember, A suffix small I is the current gain without feedback, without load. And A suffix capital I is the current gain considering RL. So transistorக்கு amplifierக்கு feedbackல we'll include load and find one current gain. We exclude load, we find one current gain. If we don't consider load, that current gain is the actual current gain of your amplifier. When you put a load resistance at the output, that current gain will be reduced form of the actual current gain. We call it as A capital I. So A capital I is considering load RL. A small I is considering the amplifier alone. So in the expression for A capital I, if you put RL equal to 0, you will get back A small I. Okay, so that is how the relation between A capital I and A small I is denoted here. So is this clear? So we have proved that when a current shunt feedback is applied, the input resistance will decrease enormously. The input resistance of the amplifier will decrease. Okay, now R naught F. So you know what is the procedure for finding R naught F? Remove this load, apply an external voltage capital V, apply external voltage capital V, and the external source is removed. Is equal to 0. So Is equal to 0 and the meaning a current illa. So this is open circuited. Is equal to 0 means the current is not there. When current is not there, it is open circuit. So this part of circuit will not be there. See, previous thing, we have short circuited Vs because Vs equal to 0. Now Is is your current source. Is equal to 0. Is equal to 0 means no current is flowing. When will the current flow be 0? Only in open circuit condition. So in the circuit diagram, input side, Is will be 0. So if you apply KCL at the input side, two currents are there. II, at this node you see II plus IF equal to 0. Or I can write II equal to minus IF. Okay, so I'm applying everything. So II equal to minus